Evening, everybody, and welcome to our 26th, I think it is, Open Clock Club. Very warm welcome. Just doing some last minute sealing wax and string alterations to the studio workspace. Yeah, as always, very warm welcome, particularly to new members, people who bought our book during the week, and Team Open Clock Club and regulars. Always great to see you regulars, so thank you for joining us. Our little bit of housekeeping: these events, remember, are recorded. They go on our YouTube archive channel, which is kind of quite good for looking back at what we've done. So if you want to remain anonymous, then please keep your camera turned off. This thing that you see is kind of half the deal here, and clock's meant to keep stopping, by the way, just in case anybody points it out. Half the deal here. The other half of the deal is this is actually nothing to do with repairing clocks. It's a kind of community social event, if you like, so that primarily takes place in the live chat. So please join in the live chat if you're in the mood for it, and say hello to Team Open Clock Club, sat in the corner there, doing a brilliant job. So as always, we've kind of got a rolling program of activity nowadays, one of which, of course, is our clock here, our single train Enfield clock. This is the clock that we talk about in our book, and we're about to recase the clock today, so that'll be good fun. It's run down, but we just got a couple of things to tie up from last week, so I'm going to put the clock to one side and get my clipboard out. We had the Facebook group is going from strength to strength. It's really kind of going quite crazy at the moment. Since last weekend, our membership has increased by just under 20%. So I'm not sure how or why that's happened. Maybe it's the robot has gotten hold of us and started to say, if you like this, you might like this. So that's quite cool. And for those people who are involved in the group will know that I now welcome everybody individually with a little note. So hopefully people have got a bit more of an idea about what we're about. So just to quickly tie up a sort of, not exactly a mistake, but a little bit of a fudge that I made last week. We were talking about escapement error, and it can't quite remember how it came about, but maybe something to do with replacing mainsprings, and somebody found the clock was gaining massively at the beginning of the week, and then it started to lose as the week went on, which is typical of all spring-driven clocks that have got an anchor recoil escapement and don't have a fusee, or in fact, the fusee isn't matched to the spring anymore. So we talked about escapement error, and I drew a diagram, something like this. So this is, oh gosh, wonky center line. This is our center line here. Just zoom out a little bit without revealing all the junk that surrounds the bench. And what we've got in the middle is a pendulum, which is suspended at this point here. The bob is somewhere down here, like this. And the pendulum is swinging from left to right. So let's just put our arrow in here. Not entirely sure I'm going to get it right this week anyway, but I do practice these things. So let's just draw in our position of the pendulum. So this is before and this is after the line of centers. The line of centers is the line that the pendulum would assume if it were allowed to come to rest. It's sometimes called the point of rest. And as I said, we're moving from here on the right side of your screen to the left side of the screen. And the point about escapement error is it's about where you put energy into the system. If you imagine your clock, the pendulum, sorry, is started swinging, you have to put energy into it. Pendulums are not self-starting. You put energy into it because of losses, because of their frictional losses that end up as heat. So that's heat generated in internal friction of the suspension spring, displacement of air, as in moving one lump of air from one place to another, and air friction, the pendulum eventually comes to a halt. So you've got to put energy into it, into the system. If you put energy evenly, I mean, I suppose ideally, don't know anything about physics, but you'd put all your energy into the pendulum to keep it swinging exactly at this point here. I guess that would be theoretically perfect, or constantly, and we can't do either of those. So our clock is kind of pushing the pendulum before, in this case, and after the line of centers. So if we put energy into the system here, so before the pendulum gets to the line of centers, we get a gaining rate, because basically the pendulum gets to that point quicker. Carry on with the color coding, Reed. Oh gosh, so many nice colors. If we put energy in after the line of centers, we get a losing rate. If we retard, so I'm going to draw the line going the other way, the pendulum still swinging in this direction. If we retard the pendulum before the line of centers, we get a losing rate here. And if we retard the pendulum after the line of centers, we get a gaining rate here. So that's kind of escapement error. And we concluded last week, I think, and nobody challenged me on it, so either people weren't bothered or it was kind of right, is that the primary reason why the anchor recoil escapement has got a net gaining effect, you put more energy in, the clock runs faster, is because if you imagine the phase of recoil here, let's just go back like this. So we've got action over and above our escaping arc. So we've got the recoil phase and then energy. We've both got a retarding action in the recoil phase and then energy in as well. So we get a kind of double whammy of gaining rate, which is why the anchor recoil escapement has got a net gaining rate. Now we did, so that's clear. Well, maybe hasn't cleared it up, but at least the drawing's right this week. It was a bit of a mess last week. We're going to talk about the deadbeat escapement as well. Not this week, thankfully, but in due course. Another thing that cropped up on the partly Facebook, but I think I'd said I would deal with this and didn't deal with it, is, let's move our little clock back, is a question about a stripped rating thread or rating note. I can't quite remember which one of those it was. So for beginners here, oh, by the way, I normally wear gloves when handling clocks, but because of the camera and focusing and things, I don't. So the rating thread is the thread, if I were to undo this the whole way, it's going to take quite a long thread, is the thread at the bottom of the pendulum that allows you to adjust the center of mass of the pendulum by either moving the pendulum bob up to make the clock go faster or letting it down to make the clock go slower. And you can see here, if we just zoom in a little bit, like this, that the bottom of the pendulum has got a thread here. Make sure my camera's focusing, and the inside of this little nut here has also got a thread. And the question is, what do you do if this thread is stripped? Because of course it will eventually strip, the threads will get worn out. Now, usually with any stripped thread, it's one thing or the other. It's rarely both. So I would say, now this is a really important point actually, because of course in these sessions we try and deal with as many kind of direct questions as we can. And this is something John, my co-author, or I'm his co-author, I don't quite know which way around it is, we're dealing with at the moment, because our second book is basically about practice. And again, I'm not going to get too distracted by talking about practice now, but it is relevant here, because in book one up there, we basically kind of teach, if you call it teaching, apologies teachers out there, by rote. So we say for this book to get started is a confidence building exercise, get a clock, take it apart in this way, put it back together again with some I've forgotten the word now, but anyway, for adjustments, reasonable adjustments for beginners. But of course, you don't carry on that way in practice. You get to the stage where there are things that there is no right or wrong answer to. The book one is just to get people off the starting line. So no right or wrong answer, but important here is that for me, we're working to 3 broad principles in terms of practice. And this is kind of changing the conservation world in which I live most of the time, is really, like all worlds, changing the whole time. But the 3 principles are minimum intervention. So once you've decided with stakeholders and maybe non-stakeholders as well, kind of thinking about that, but it's making smoke come out my ears, where you want to be at the end of your part of this project. How are you going to get there? By just doing what you agreed and nothing more. So you kind of don't do stuff because it makes you feel good or that kind of thing. The concept of reversibility, which is a slippery animal at the best of times, but put as basically as we can, what you do is intended to be reversible or the maximum retreatability. For years, I thought that was retreatability, as in going back, but it means doing it again. In conservation, there was a kind of a fashion for something called soluble nylon. I think it was used as a consolidant or an adhesive, probably back in the 80s. And it was like super fashionable, but people began to realize that it wasn't particularly undoable. So that's our second principle, retreatability. And these are only principles, they're guides. And the third and critically most important one is accountability. So you have to, there's no have to, of course, but let's just let somebody in there. You have to say, Matthew, why did you do that thing? And you have to have reasonable kind of say, well, I did that thing on that day for these reasons. That's the kind of accountability thing. And the reason I talk about this is because we can't obviously deal with every single case. So you as practitioners will build up your own set of sort of values or terms of reference or professional codes. Some people call it ethics. I don't particularly like that term, but anyway. So in this case, let's say the nut was stripped, the thread in the nut was stripped. You can make a new nut. You could add to this one. I was trying to look for a picture. I'll put it on Facebook. I think it wasn't the right kind of answer, but there was a tavern clock once where the rating thread had stripped, but there was enough thread underneath to take another nut. So I made another new one and put that on, leaving the old one as it is. But of course, the problem with that is, as the years go by, you end up with about 10 different rating nuts on it. So that kind of doesn't work. You can drill out and put a plug in the rating nut and retap that. Again, sort of minimum intervention type thing. You could put a bit of wood in there. And the same thing for the thread. You can try and remake the thread if you've got dies, that are not cutting dies, but rolling dies, sort of, what do they call that? Not displacement, but of material. Anyway, come on, brain. You could try and remake the thread, or again, you could remove the minimum amount of thread and you could solder in by soft soldering a new rating thread. So there are really lots of ways of going about these things. And I think the point is...
We've got some suggestions.
All right, what are the suggestions?
Derek says bush the nut and retap.
Bush and retap. Good suggestion, Derek. Thank you.
Devashish says use plumber's tape on the rating screw.
Right, and this, I love this. But I warn you, Devashish, that if you, I'm totally for that. So this is use PTFE tape on it, like you would kind of on an outside tap that was dripping or something. And that's great. I love the idea of using sort of modern materials, glues. You know, we talk about Loctite and all that kind of stuff. So no problem with that whatsoever. However, part of developing those kinds of ideas is that, and maybe, you know, I think you just have to develop a thick skin for these things, because you will be pilloried for saying that, and it will be called, maybe it might be called a bodge or da-da-da. I'm getting better at having a thick skin over that kind of stuff, having been in conservation for 20 years or something. But I think that's a great idea. But the point is that, and I hope that's a kind of a typical sort of point of these sessions, it's not a course, is that there is no right or wrong way, and we're open to those kinds of ideas. So thank you for that. My point is that as we develop as clockmakers or repairers, we inevitably, whether we like it or not, whether we call it practice, we're developing our practice. And our second book is going to be called Establishing Practice. So not developing, but actually thinking what it's like, because of course, the whole time, every day, day in, day out, we're faced with these questions to which there is no right or wrong answer. Two more questions.
From Matthew Shore.
Hi, Matthew.
Assuming the clock is set to keep the correct time, since you don't have to keep adjusting the set nut, will threads still wear out?
They do wear out, funnily enough. I mean, it's obviously going to last a long time. I think what happens on long case clocks, and I don't know whether this was a long case clock or a tall case clock, is unlike this pendulum bob, which is relatively light, I suppose, compared to a lump of lead on a tall case clock, is that what happens is, because they're oldish clocks, the bob gets oil inside it. It either drips down from the crutch or dirt goes in there or spiders or whatever. And so it actually becomes very difficult to move it up and down the slide. So maybe that thread is under a lot more sort of force pressure than it would be if the clock were new. And I suppose ideally what you would do is you would lift the bob up a little bit, kind of like you do on one of those regulators, move the thread up. You don't put all the weight of the bob on the thread. So the answer is yes, it will strip again, but I think that's without going off on some pseudo philosophical rant again. We think about that we can't help, you know, being creatures that love a bit of fiction. We can't help thinking what happens in the future. But how I see that kind of being used a lot in clocks is this kind of disaster situation. Oh, we've got to do this and got to do that and got to do this to save something where this is going to break and it's caused this and the whole world's going to grind to a halt. So I would try and push back a bit on sort of disaster scenarios. And we have to think what is reasonable. Which leads me to, well, I'll get the clock back in the case in a minute, but it leads me to this idea of guarantee. I never, with my practice, and this might come as a surprise, and I'd love to know what you do and what you think and what you say to your clients, the people who are repairing clocks professionally or otherwise, is do you offer any guarantee? I never offer a guarantee with any of my work. I just think it's impossible with 17th, 18th, 19th, and even 20th century clocks. There's so many things to go wrong. I just don't offer a guarantee. I mean, what I do, of course, is I go back and I'll repair something. And if it's reasonable, I put it right for free, sometimes for a couple of years or something, but I don't offer any explicit guarantee. Personally, I think you are just opening yourself up to all sorts of problems there. But I'd love to know what you think and how you get around that and how you approach that. I've seen some people say, like, I offer a 5-year guarantee. And I think if my client were to say, how long is it going to be guaranteed for? And I says, it's not, but I'm reasonable. I'll come back. And if it's something I think I've done or whatever, we'll put it right for free. No problem. And if they said, no, I want a guarantee, it's kind of an insurance, isn't it? I'd want to charge them more for that. A bit like when you buy a microwave oven and then they email you and say, this has got a 2-year guarantee. Do you want to extend that to 10 years? All that is an insurance policy, isn't it? So maybe that's the way around it, but let us know what you think. More.
Wolfie says, is it worth lubricating the nut with a dry lube like graphite to help reduce wear?
Definitely lubricate the rating thread. Absolutely. I think it's in the book. In fact, it's John will know, it's on page something towards the end. Definitely lubricate the thread. Yeah, and you could use graphite sort of dry lubricant as well. And I suppose that's the good thing about the PTFE tape solution is PTFE is a lubricant. So yeah. What else, Rachel?
David Sheesh offers a permanent warranty to his customers.
Right, okay. What does that mean? Forever?
Yeah, yes.
The clock mainspring breaks, isn't it?
He only has one customer.
All right. It's interesting. I think the whole warranty thing is fascinating. I watch the occasional YouTube video about people repairing cars, and you know, those things they go out the door and they break straight away. Of course they do, and then they're only 30, 40, 50 years old. These things, and even this relatively modern clock is sort of older than that. But anyway, so let's get on to the business of the day, which is getting our clock cased up. You will remember we made a nice little test stand. So the clock's been on test. I haven't had the hands on it, so I don't know whether it's been keeping time, but I'm not particularly fussed about that. But interestingly, it's run down. You can see I keep starting it. It's run down. It's not because it's faulty. And I think it'd be quite cool to do a little experiment, see how far it's run down. The other day, I'm not sure this is the same actually, but John and I did a calculation that the full wind on these clocks, that's from when the spring's been out of the barrel, is 8 turns. So they actually are that's the two train clocks. I presume these are the same because they look the same size mainspring. Is 8 turns. So that's 2 weeks worth of running. And it'll be interesting to see how much wind there still is on here with the whole thing run right down. So yeah, the clock's been on its test stand, getting nice and dusty, just like we like it. And it's time to put it back in the case. So let's just liberate it from here. Nice screws. Oh yeah, the point of the test stand, of course, was to show people setting up the escapement and putting the clock in beat, wasn't it? I remember now. Cheeky. On this little chap on top, I think that can stay there. Sam, I think, pointed that out last week as a non-original Smiths Enfield edition. This little thing here, if you remember many or several months ago, I was using this escape wheel and these pallets to demonstrate drop, internal drop and external drop. So just going to throw the test stand over to Rachel and go on the fire now with it. Joke. Right, okay. No, it'll be very, very useful. Right, okay, so there's our little clock movement. All done. So you've had your clock on test, double, triple check for lubrication. It's easy to miss a bearing, and then maybe, you know, this room's quite warm, as are most centrally heated houses nowadays. So I would just go through the train and check that you can see visible lubrication. Now, we're probably, the only one we can't do here is the front barrel arbor bearing. Let's just zoom a bit. So we can't check under here, but we can get the mobiles with a pair of tweezers, give them a wiggle and look through a low power glass, an eyeglass or a magnifier, or even through a camera feeding to a monitor or something, and check that we can see a little bit of liquid oil in all the bearing holes, because this clock's going to go back in the case and it might be there for, well, who knows, years and years running away. So just check that, add a little bit more lubrication if necessary to the pallets, and also don't forget when it goes back in the case to check that the interface between the crutch, or the leader as it's called sometimes, and the pendulum is lubricated as well at both sides with a bit of thick oil, which damps the whole thing down and quietens it down. So I'm just going to spend 1 minute just having a little look around inside. There isn't a lot of, I've probably already oiled this at least twice. Of course, what you don't want to do is to oil to the degree that oil begins to run out of the holes and down the plates, because that's actually going to be counterproductive. Yeah, okay, so we're good. That's really worth doing, because of course you don't want to be laid at night thinking, oh gosh, did I oil that bearing or this bearing? So the case, just pop that to one side. This is here. I'll just zoom you out a little bit. And you can see it's, actually see a thing. Let's just get rid of that. It's Bakelite mid-20th century typical Smiths Enfield case. The glass has got a little fracture in there. I don't know if you can see it, but it's doesn't, I mean, it's a running crack, so it probably will continue to elongate over time. The problem with that type of fracture is even with that material that we talk about called Hextal, HXTAL, which is a very low viscosity epoxy resin that's got about the same refractive index as glass. I don't think it's going to get into there because, of course, the gap is so tiny. So I've disassembled the case, cleaned the glass, cleaned the bezel, and you can see that the dial is quite rubbed. So presumably at some point, somebody's maybe tried to clean it, or I don't know. And because it's printed, not engraved and waxed, then I'm perfectly happy to live with it as it is. My interest in this was kind of getting anything sort of three-dimensional off dirt, or not dirt, dust, or stuff that was on there. So I've vacuumed it, cleaned the bezel, taken it all apart, and I've just thought I'd show you the most important thing is, of course, inside here, because we don't want to put our lovely clean movement, even though it's been hanging around for a week on our test stand, back in this case if there's dust in there. And this is something that I see time and time and time again, that people don't seem to do. It takes about 2 minutes. Vacuum out the inside of the case before you put the movement back. Sorry, as that sounded bossy, you might want to consider vacuuming out the inside of the case. And to that end, somewhere, I've got my tube, or my tube. It's big enough, I can't block it. There it is. Here we are, eBay tube. So I've got a thing for my vacuum cleaner, and got my super special brush that I love so much. And it's got the thing on there, all linked up. So I have already done it, but just for sake of demonstration, I'm going to vacuum out the case. If you don't vacuum out the case, why not? Gosh.
Mark says he's still planning on making a replacement click spring today.
Yes. Is that what he's here for? Okay. Right. So we're going to vacuum out the case. Like so. Demo. And pop our movement back. Try and get it in there and get it in big, because we've got half an hour to do the click spring. Now, we've talked about this before somewhere, I can't quite remember where it was now, but, oh, I see. We talked about holding these screws in the back of clock cases. Some people use a screw grabber, sounds like some kind of nightclub bouncer. And some people use a bit of plasticine or Rodico, which is what I do. Look at this.
Is the crack in the glass due to be touching the glass?
No, I think what it is, Jeremy, is that I think it's probably my fault. We've got a few of these clocks and I keep them in a cupboard, and I think the glass touched on the back of another clock and probably cracked it that way. But sometimes on long case clocks, you see the arbor is so close to the inside of the glass, particularly those sort of nice, he says nice, those sort of late 18th century ones that have got a low parallax, that you get a little oily mark on the inside of the glass. The end of the arbor is so close. I'll just pop a couple of screws in now. And the only reason I don't want to do this is to demonstrate getting the thing in beat when it's in the case and how you do that. I'm not sure how successful it was last week, being able to listen to that process, but let's not spend too much time on it. So yeah, thinking ahead to the next job tonight, and that is we got through our website an inquiry about where you get click springs for Smiths Enfield clocks. Now, there are, as far as I know, there's a hazard of using a bit of Rodico to do it. It falls off and gets jammed in the movement, and then a week later, clock stops.
Said, can plasticine be used to clean movements too in lieu of Rodico?
Don't think so. I wouldn't. No, I wouldn't use plasticine in lieu of Rodico.
You did say plasticine or Rodico.
To hold the screw, not to clean it. Just to hold the screw. No, I imagine very similar looking kind of thing. So there we are. Just put 2 screws in for now. Let's give it a bit of a wind. Just go find the key. Yeah, I was really quite surprised. I think that's quite an interesting experiment, actually, when you've got your clocks on test, to let them run right out and see how far they've run down. That might give you an indication of the health of the repair of the clock. So let's have a little look here. You heard the spring settling there. Ah, no, you didn't hear the spring settling. Okay, there we go. So I've totally lost count of how many turns that was. Was that 6 turns? Something like that? I don't know. Anyway. Oh, no, the spring, I think, has come off, isn't hooked onto the barrel. So classic amateur schoolboy error. When I put the spring back in the barrel, I'll put the barrel arbor back in the spring. I haven't read the book, which tells you to check again that the spring is actually hooked on. It's not hooked on the outside of the barrel, so it's not the spring settling, it's the fact that the spring is actually not hooked on the outside of the barrel. So clock has to come apart again. Da-da-da. Okay, there we are. Oh well. Read the book and be thorough is the answer. Don't be in a rush. Okay, so maybe it's time for a 2-minute comfort break while I get organized with the next bit. Yeah, let's have a comfort break while I find the next clock, and we'll reconvene at 35. Okay, give you a couple of minutes to have a break and a swig of tea. I'll just go on mute. Yeah, I've had that that happened to me several times, and it's fine when it's a clock like this, of course, single train. get it apart, 5 minutes, hook the spring on, and it's okay. It's slightly more depressing when it's a 3-train Busey clock that takes about an hour and a half to get everything back together again. But it just happens. So the lesson learned there is check, check, and check again when you've had the spring out the barrel that it's hooked on, particularly on the outer hooking, because you might wind it like half a turn with the key and think, oh, it's fine. But in that case, of course, it wasn't. So we had a question on our website that was about replacing these springs here, these click springs when they're broken. Where do you get those from, was the answer. And maybe you can buy them online. I don't know. It's kind of a cost benefit exercise, isn't it? Is it better to go online, order one, pay the postage, which is perfectly fine for some things, but you can't get a click spring for a Joseph Nib spring clock, for instance. You've got to make one of those anyway. So it's kind of a useful exercise. And again, without over romanticizing it, you learn more about materials manipulation. You learn about craft. It helps you interpret other clocks because you can say, ah, right, I get it now. That's why they did it like that. That's why it looks like that. And so there are obvious benefits to making stuff, and there are obvious benefits to buying stuff, and there is no wrong or right thing. I think it's worth having both those things in your armory, those options. So here on this side, we've got a spring made out of steel, and it's hardened and tempered. And on this side, the tail of the spring is broken off. Now I could try repairing this by hard soldering it, but I thought this is a good opportunity to demonstrate making a new one. So what you could do is to make one using steel. Now this opens up another can of worms about what I think is a bit of an obsession about using the right material. It was interesting, again, the Facebook group this week, we've got somebody making a component for a probably 17th century clock using cast brass, which is no problem with that, perfectly happy with that. But I personally am not that fussed about that. If you're making a new part, doesn't really matter, you know, what the material is, particularly if it's not visible, although even if it is visible, I could argue both ways. So the obvious thing is to make one of these out of steel. Well, if you do that, that's great, but you need a piece of 0.5 millimeter thick carbon steel, so something that's hardenable and temperable, if there is such a word, and you would use this stuff. So where are we? Something like this, which is ground flat stock or gauge plate. There's the label, oh, upside down. But anyway, ground flat stock, you can just see that there, yeah? Which is really cool stuff. I think this is the thinnest you can buy, and it's 1 millimeter. So you're gonna have to file it down. So you can file it down. It comes in its annealed state. So it's sticky, but not impossible. Bend it to shape. Then you've got to harden it by heating it to red and then quenching it. And then you've got to temper it back. All those things perfectly reasonable. But the problem is when you harden steel like that, unless you've got specialist equipment, it's going to be covered in fire scale. So the oxides from hardening, and you're going to clean all that up. So it's a pretty major undertaking to do that, but that's an option. The other option to save you having to thin that material will be to use a bit of old mainspring. This spring is 0.5 millimeter. So a bit of old, you know, Busey clock mainspring, 0.45, 0.5 millimeter would do the job. But again, you'll have to anneal it, flatten it out, bend it to shape, obviously reharden it, and then temper it, and then get all the scale off it. So all those things are quite time consuming, no problem with those. But the way I would go about it, if you can get your head round fitting a brass spring, is to fit a brass spring. And the material I'm using here, and you can see I've started on this end, is CZ108. Now, if you're following the live stream on Thursday, then you will know about this because we've been using this material. Don't use the more common CZ120 or even worse, CZ121, those leaded free cutting brasses for making springs, because they're very liable to fracture. This stuff won't fracture. Well, he says it won't fracture, and it makes a brilliant spring. Brass springs are really good. In fact, I think there are some American clocks, aren't they? American clock people out there with brass springs, even coil, spiral springs. So CZ, but I'll write it on there, CZ108. There we are. Non-leaded brass. So this has got really good cold working properties, but because it's no lead in it, it's also very sticky. So you wouldn't want to turn this, for instance, or even drill it. It's a real pain. And we talked again on the live stream about changing the profile of the cutting edge of the drill to prevent it from grabbing, which is an incredibly useful point and important for health and safety. So I'm just going to saw along here, and then in the next 20 minutes, hopefully get the spring somewhere near. So this has been hardened. When you get this material, it's rolled, and I think it's half hard. So it's not fully hardened, and you harden it by working it, by hardening it. And I did that with my trusty bench block, which is a block of hardened steel, and I hammered it. Simple as that. Don't need to do this again, but literally working. Sets the dog off. That's why we don't want to be hammering. It's not my dog, by the way. But anyway, working the surface, and you can feel the material change. It's great working with this material because you can anneal it by heating it and making it soft, and you can harden it to any degree you want within reason until the point that it cracks by either rolling it or hammering it, as you've seen here. Now, I suppose one point about that is it going to work harden when it's being used? Well, that is, let's just get our ice out here, piercing saw table. Maybe this is where you get to see all the junk that's under my bench, but let's just have a little move of the camera down here. There we go. Is that going to focus? Zoom out a little bit. Yeah, it looks close enough. Right, okay, so let's just finish the sewing. Might sew in this direction. Leave my sewing glasses on. So I just marked out from the old spring. Just going to quickly sew along. You see what we're doing there? Yeah, great. Now it's quite sticky to sew it. Well, that's as deep as the sew will allow us to go. So it'll have to be long enough, which is loads long enough, I'm sure. Let's just put it off. Go and just break it off. Cool. Right, back to the bench. There a little bit.
Matthew, did you already make a brass click spring on the live stream?
Yep, I did. Yeah. There's something different. Yeah. This is a spring for a Smiths Enfield mantel clock. Right. I mean no, in principle, this is basically the same process, but unless you're willing to work your way back through the live stream, it's the same kind of thing. Come on. Anyway, I'll leave the camera to focus while I find the bench lights.
108 have a different name these days?
Yeah, probably. Yeah, sorry about that. CZ108 probably has a completely different name, but I'm sure one of you super clever people can find it and we can put it in the live chat. It probably has an EN number, does it? Or is that steel that I'm thinking about? So if you haven't seen the live stream, shame on you. But anyway, I take it that people have got better things to do on a Thursday. What we did with that spring, you can see this one here. The problem with uniform thickness springs, like the one that's on the clock, is if you bend it at this end, it only obviously wants to bend here, and that's where it's going to snap off. So what I'm going to do is to taper it along its length in terms of thickness, because like your mainsprings, he said, getting back on my mainspring hobby horse, the problem with replacing a mainspring is that if you change the thickness, the strength of the spring is relative to the cube of the thickness. So a little change in thickness makes a massive difference to the strength. If you say, oh, it's okay, I'll just put a slightly thicker spring in. Nice file here, look, it's been used as a scraper as well, ground the end away. So let's just quickly do this. So yeah, there's a version of this on the live stream. Just get, it's going to be pretty rough, but no change there. And in order to get the spring so it behaves in a nicer way, so it curves more evenly along its length, we're going to thin it along the length. As my old tutor Roger used to say, think of like a tree branch thing, you know, they're not uniform lengths, otherwise they'd all break off where they join the trunk. Or something like that anyway. It's going to work. I'm just going to file down. When I was thinking this other day, as you do, I was thinking about, not that I've had much to do with marine chronometers, but marine chronometer mainsprings. I think they were tapered in thickness, but not for the same reason as this. They were tapered so that they developed evenly in the barrel. I think they were thicker on the outside, which is kind of slightly counterintuitive. I'm going to thin. And see what I'm doing yet. Yeah, doing more at the outer end. And then just like the thing we did on the live stream, keep testing it. So bend it like this, and you can see it's not bending here at all. It's remaining straight. Now again, the CZ108 is a total pain to file. And has anybody come up with what they call CZ108 nowadays? Both, right, thank you. 508L. CW508L. Yeah. All right, okay. So again, a bit more. And so on. And so you keep filing this metal away. Remember, we're not particularly interested in the width of the spring, because the width of the spring is proportional to the strength of the spring. So if you half the width, you half the strength. Whereas on the thickness, it's this cube law.
Matthew Shook says, is that cork, the block?
Yes, yeah, it's a decorator's block. Yeah.
Is that his vice?
Yes. Yeah. Yes, John's vice. It's not John's vice, but yeah. So I just want, you see now it's beginning to bend more evenly, still got a bit more to come up here. Now, this raises a really interesting question about improving things, doesn't it? And I'm not a fan of improving things, you know, going out of my way to say, I'm so, you know about this thing now so I can make it better. However, we're making a new spring. do you therefore have a kind of opportunity to do something that's what you think is better? I don't know, kind of, again, from a practice perspective, whether that holds any water or not. Probably not. Anyway, cool, got 10 minutes. So let's say we've done this to the degree that it is bending nicely. It's still too thick here, isn't it? Because it's not bending much there. But I say, if you want to find out more about this, go to the live stream archive. We did a rack spring, wasn't it, over the last couple of weeks. Interesting, as a file, it curves up like a bit of paper. That's quite cool, isn't it? So more filing needed. So a little bit of draw filing without buckling the whole thing up and ruining it. Rubber. Yeah. The cork block is incredibly useful because it just is compliant enough to actually hold the work without having to. You can maybe see on there, I've pinned it before when I was cutting this down from a bigger piece. But yeah, the cork's just compliant enough, really useful. And also what it does, it acts a little bit like a swing tool. So if you imagine, here's our other bit of material that we're filing. Say we're filing this pair of tweezers. When you put your file on, look, hailstorm here, that's cool. The work and the file work together so you can get nice flat work. And of course, crisp angular detail is a hallmark of horological manufacture, which is why I don't like abrasive paper in the repair of old clocks, because it makes things squidgy. So just tidy up the sides a bit. This is obviously not going to be a thing of great beauty, but it shows the principle that you can make a good spring out of a bit of brass. Did we get anywhere with the American clocks with brass springs? Answer? Yeah, I think I seem to remember that there are American clocks that have got brass springs. Right, okay. Now, I can draw this that I've got going. What I'm looking for is the spring, so I don't bend it in the wrong direction. This would be moderately unfortunate, wouldn't it? So it needs to fold over this way. Just pop it in the vise of jaws of John's vise. Is that okay, John? Yeah. Squidgy is a polite way of talking about people who use abrasive paper on old clocks. So I'm going to try and get this the correct height, obviously. Looks about there, but just find something to tap it over with. Bit of wood. Boxwood. Go, just file that down without filing onto the jaws of John's vise. Too much. Right, okay. So what we're left with here is a rounded corner, which is kind of like the thing is when they're made, because it's just made on a machine. But it's quite nice to file a bit of a little bevel on there. You see this on the rack springs and things of old work, just to get rid of that external radius. Just smarten it up a little bit. Right, okay, let's look at our clock plate. So
Nick says, what is keeping the vice still?
Nothing.
Right.
Just skill. Or okay, so you can see what I'm going to do. I'm going to obviously, I think that I shouldn't have bent the tab of the spring round. That actually isn't bent on this. I've probably done it wrong in the first place. It's formed in a different way. So there we are. This piece is actually changing rather rapidly from what it might have been when it was new. So we can bend that back, I'm sure. Anyway, so the next thing to do is to think about the rivet. And again, this is another kind of one of those practice questions that these components, we don't know what the manufacturer was thinking when they made them, what their sort of rationale was, whether they said, doesn't matter, this never has to be removed, the clock's going to be worn out and people will throw them away. But there's no manufacturing sort of way of removing these rivets without destructive action. So again, what do you do there? In this case, I punched it out and it punched out quite easily. So do you rivet again, or do you put something like a brass BA screw there? You could put a BA screw, a machine screw with a nut on the back. But again, a bit like the question of using the PTFE tape on the threading rating nut thing, is that classed as a bodge? I don't know. I don't mind. It's pretty obvious what has gone on. If you saw a clock and it had a BA machine screw on it with a nut on the back and a little washer, perfectly serviceable. It means the next person that has to replace this doesn't have to go through the process of drilling out or punching out the rivet. But is that considered bad practice? I don't think there is such a thing per se as bad practice in that respect. So pretty open-minded. I'm actually going to remake the rivet, and I'm going to use a taper pen. So how are we doing for time? Oh, we're going to run out of time. So to be continued next week. But I hope that was useful in terms of making our spring. You can see we're going to be able to bend it round here next week and fit it to the clock. But the last couple of minutes, just going to show you how I'm going to make the rivet. If I can just get my lathe up. It's here somewhere.
What about pop rivets?
Yeah, I don't know anything about them, Jane. Sorry. John knows everything there is to know about pop rivets. So John, come on in the live chat. Can we use pop rivets on clocks? I'll squidge up as far as I can get here. Camera's not perfectly angled. Let's just move a little bit.
John says, can you get pop rivets small enough?
Well, I don't know. That's the kind of question, really, isn't it? So I've got focus. Yeah, it doesn't look too bad. I've got a taper pin here, and I've marked on from the plate where the places that the diameter needs to be. It's all a bit dark in there for some reason, isn't it? Anyway, so I've marked on there with blue, and what I was going to do with that bush that I've now dropped is to use that to file against. So I don't know if you can see there, it's a little bit indistinct, but on the pin we can see that's as far as it went into the hole. And this is really the key, he said, looking for the bush, which I think I've lost. This is really the key to getting rivets to work. Make sure that they fit both components well in the first instance, like we did on the click spring on the live stream, because if they don't, you're just going to have to be hammering away to try and get it to work. What you want is a rivet to be a really good fit, the material, whether it's brass or steel or iron in this case, to be soft so it rivets easily. And then you don't have to start whacking the whole thing. For brass, a good riveting brass is, and again, you can look at what the modern equivalent is CZ131. That's got really good sort of riveting properties. We used to use that for making clock pillars. and so on. So I'm going to file, we're run out of time. So I'm going to next week continue this. I might remake the spring a little bit neater, and we'll bend it to shape and rivet it on. And the point of that bush, which I've dropped on the floor, was so I don't file against the collet of my lathe. It's just loose on there, running bush that's going to protect the collet from filing. So I'm going to turn this down to a rivet, and then we're going to pop that on first thing next week. I'll also get that spring out that's not hooked on the end of the barrel and demonstrate to people what's happened there in case you're, again, a beginner. That's a really useful lesson to learn, because it's really quite demoralizing having just got your clock together to find that the spring needs to come out of the barrel again. So made some progress there on making our spring, which I've lost, and we'll finish that little thing next week. Keep up with us on the Facebook group. There's some really good advice there coming in from all sorts of different people. So thank you to those people who contribute to that group. Really appreciated. You're doing a brilliant job. Might see you on Thursday for the live stream, where we are, we're repivoting center wheels. If you want to know about pivoting and pivot drilling, join us on Thursday at 6 o'clock British Summer Time, or you can find us on YouTube recorded later. And that's quite cool, because we were looking at different ways of work holding, which is always a challenge when using our lathe. And thanks to Open Clock Club, Team Open Clock Club in the corner there, for keeping up with the live chat. And if we don't see you on Thursday, or we don't see you on the Facebook group, then hopefully we'll see you next Saturday, same time, for episode 27, I think. And we will get this job finished and see if it clicks. Okay, bye for now.